Hello guys, this is Paul McWhorter with TopTechBoy.com, and I am here with lesson number 26 on learning to use your Raspberry Pi. If you've been through our first lessons, you already know how to install the software, install the operating system, get the Raspberry Pi booted up, and you've learned quite a bit about Linux, how to find your way around the system for a Linux-based system like the Raspberry Pi. What we are going to do today is we are actually going to go in and start building our first circuit, and this is what everything has been leading up to. And if you've been through our earlier series of lessons on the Arduino, you really know that the Arduino is a great little microcontroller for controlling the pins and working with circuit elements and working with sensors and actuators. And the thing is, though, you finally just reach the point on a Arduino that you just run out of horsepower, and you need something with more memory, with faster speed, with more computational resources. And so then you move up to the Raspberry Pi. So that's what we did, and then we've gone in on the Raspberry Pi and we sort of learned how to find our way around on the system. But now we want to start working with a circuit like we did back in the Arduino days. So what we basically have to do is we've got to learn how to interact with these GPIO pins. GPIO stands for General Purpose Input-Output pins. And we showed in the last lesson, which was lesson 25, we showed you how those pins are configured. What's what in those pins. Let me see if I can scoot this over a little bit. And I've sort of laid it out here. You can see that on the Raspberry Pi Model 2 there's 40 pins, and this is showing you what different things you can do with the different pins. Go back and look at lesson number 25 because we really explain things fully there. The one thing that I'll sort of say is we're getting ready here to start interacting with these pins. There are two different numbering schemes that you can use, and you determine those which numbering scheme you're going to do with a GPIO.setMode command. But basically you've got to decide, are you going to use the physical pins, which are kind of numbered really easily, 1, 2, 3, 4, 5, 6, 7, 8, which would be over here 1, 2, 3, 4, 5, 6, 7, 8. That's the physical pin numbering system. Or are you going to use the GPIO numbering system? If we're using physical pins, this pin here would be 3 because it's 1, 2, 3. If we're going to use the BCM numbering system, then this would be GPIO 2. So you can see what pin this is is a function of what numbering scheme that you're going to use. I like using physical pins because I can always look down even if I don't have this chart, and I can figure out what the pin is. So I like physical pins, and we will show you how to set things up for that. But just a reminder that this is the pin out. Okay, let's get this back over here. And what I need you to do now is go ahead and build this circuit. If you got the kit that I suggested in lesson number 1, then you have everything that you need to do this. If you haven't gotten your kit yet, you need to go back here. Remember, this is lesson 26. Go to TopTechBoy.com. You can come over here to Raspberry Pi with Linux lesson. You can come down and select lesson number 26. And then here I show you a link where you can buy a kit that will have all the things that you need to go through this whole series of lessons that I'm going through. Or you can pick up the parts as you can. If you already have a Raspberry Pi, you can just try to pick up the parts as you go. All right. So let's look at this. What we want to do is we want to hook up this circuit. So this should work, I think, probably for most of the earlier Pi models as well. I think the numbering scheme should work out the same. But let's look at what pins we're using. I want to come up here, and we can see that we're going to need a ground. And I can see that my first ground, or a convenient ground, is pin 9. So I'm going to use pin 9 as a ground. So I would come over here, that'd be like 1, 3, 5, 7, 9. It would be that pin. And then here in the real world, you can see that this would be pin 1, pin 3, pin 5, pin 7, pin 9. And so you can see that I have my ground wire hooked up to pin 9. Okay, let's get back and look at the circuit. So I've got 1, 3, 5, 7, 9. So I have 9 coming to ground. Then I have ground coming. I like to set up a ground rail in case we want to add more LEDs in a minute. I have the ground coming to my current limiting resistor, which is a 330 ohm resistor, then my LED, and then the power line of the LED going to pin 11. So we're using physical pins 11 and physical pins 9. You guys remember that it matters what direction you put the LED in. The LED, the long leg of the LED, always needs to point towards the power, and so the long LED is coming up going to control pin number 11. So I need you guys to go ahead and get this hooked up, and then we're going to go and we're going to see playing around with these pins. Okay, I'm going to assume that you have it put together at this point. So what I'm going to need you to do is go to your terminal window on the Raspberry Pi. And if you've been following these lessons, you're booting in the terminal window, and so you should already be there. You probably should be in your home directory, and then what I've done is, if you look at ls, I have created a folder called My Python, where I'm going to keep my Python programs. And so that might be a good thing for you to go ahead and do. You would do a make directory, and then you would say or make directory, and you would say My Python. Okay, and then that'll put you a directory there, something to work in and something to put your your Python programs in. All right, but to start with, sometimes when you're trying to just get a feel for things and trying to learn exactly what all these pins are doing and how things work, it's easier to run from the shell than it is to actually write a program. And so basically running from the shell it allows you to enter the lines of the program one line at a time, and you can kind of see what happens. And it's just sort of a little better way of learning something, I think. So to start with, start by just running in the shell. Well, how do you get to the Python shell? Well, you would just type in Python, and then it would bring you to the shell like that. Okay, boom. And then where you see these three little things, it's now not wanting Linux commands, it's now wanting Python commands. This is the problem with what I've just done. Your default user, Pi, who most of us log in as, Pi doesn't have access to the GPIO pins. He doesn't have enough permissions. And so what you have to do is you have to give these commands as sudo, as super user. So let's exit out of the shell. We exit out of the shell with Control D. By doing Control D, you can now see that I'm back at the Linux window. Okay, this is what you want to do if you want this to work, and it's very important. You have to say sudo Python, because what this will do is this will open up the Python shell, but it will interpret all of the commands as super user. So now whatever I tell it to do, it'll do it, because it doesn't look at me as lowly Pi, it looks at me as sudo, as the super user do. Okay, so now how do we control these pins? Well, we got to do some bookkeeping to begin with. Okay, the first thing we need to do is import, and then we've got to import a library. It's case sensitive, capital R, capital P, little I, dot GPIO. So we're going to import that library as GPIO. Okay, all caps, capital R, capital P, little I. Okay, now that imported the library. If you get an error message here, understand that the recent implementations of Python the recent implementation of the Raspberry Pi, the distributions include this library. If you are getting an error, you need to go back out of this Control D and do a sudo apt-get update and a sudo apt-dash I'm sorry, let me show you. I'm having trouble saying it. I'll Control D out of here, and what you would need to do is just do a sudo apt-get update and click enter. If you haven't updated in a while, it might take 15 or 20 minutes, and then after that you want to do a sudo apt-get upgrade. Okay, and then when you do those, you will have the library. But you only have to do that. You only have to do that if you get an error message. And so let's go back here to sudo Python. Okay, so now we're back at the command shell in Python, and so what do I want to do? Import rp_i.gpio and then as GPIO. So I'm importing the library as GPIO, and it is happy, which is very good. Now what we have to do is we have to tell Python and Raspberry Pi what numbering scheme we're going to do. Do we want to go with these numbers, the physical pins? Well, if we do that, we want to use the board numbering scheme. Or do we want these numbers out here? In that case, we would use the BCM numbering scheme. I like the physical pins, so that's what we're going to do. We're going to do the physical pins. So to use the physical pin numbering system, I need to do GPIO.setMode. Okay, and I'm going to go GPIO.BOARD. Okay, so this is going to say to use the board numbering scheme on the pins, and it's happy. You can imagine if you wanted to use the other numbering scheme that's on the outer columns, you would do BCM like that. Okay, but I don't want to do that. We're gonna do board, BOARD, like we did. It should it should be happy. All right, now remember when you were setting up your Arduinos, you would have to do a pin mode to tell the Arduino whether the pins you were doing were inputs or outputs. You got to do the same thing with the Raspberry Pi. You got to tell the Raspberry Pi whether a pin is going to be an input or an output. So this is the way we do that. We're going to do a GPIO dot, okay, and we're going to do a setup, okay. What pin are we using? Well, remember the pin that we're actually using is pin 11. Let's see if we can go back and look at that. I think I need to go back. Okay. If I look at this circuit, you can see I'm doing 1, 3, 5, 7, 9 is ground, and then I'm doing 11. So I am doing pin 11. So what I would say is 11. Okay, and then we're going to go comma GPIO dot out, because we're going to want to send signals to it. We want to make it an output pin. Let's look at that. It is happy, so that is very good. So we've got that pin 11 is set up as an output pin. Okay, now how could I take that pin high? I could take the pin high by saying GPIO dot output, so I'm going to output to it. What's the pin number? It's 11. How do I make it go high? I say true, capital T, little r, little u, little e, and let's see. Boom! Look at that. The LED came on. I was able to make the LED come on. Well, how would I make it go off? Let's say false. Boom! I made the LED go off. I'm wondering, let's just see, I wonder if I could just set it to a 1. I'm wondering like a 1, if that would work. Yeah, that works too. And similarly, the analogy would be a 0. So you can set it to a 0 or 1, a true or false. What you can see is that we've configured this as a binary output, as a digital output. It can either be high, which for the Raspberry Pi I believe is 3.3 volts, or 0, which would be low. So you can see we can control this pin. This is really great. One thing we always want, so you can see now you have the basis now to start doing things in a program. We know how to set up the pin and we know how to control it. One thing, anytime you're done with your Python, it's good housekeeping to always come in and say GPIO dot clean up and then open close like that. And what that does is basically it sort of releases those pins so that you can use them again later. Otherwise, you'll start getting errors if you go back and try to use them again. Okay, let's do a Control D and let's get out of there. And now what we want to do is let's see if we can actually write a Python program that would do something. So let's do let's see. I'm sorry. Okay, so I don't like typing the path names over and over, so I'm going to go down to my Python. Now I'm going to nano to create a program. What program do I want to make? Let's call it blink.py. Good housekeeping, always name your Python programs with a .py. All right. Now, ooh, look at that. I'd already been playing with that file, so let me get rid of all that. I actually practice. I actually practice this stuff before I come on here, so make sure I know what I'm doing. Okay, so if we're going to write a Python program, what is the first thing that we need to do? Well, I do want to sort of have it on and off and make it blink, and so I'm going to import the time library so that I can use that. Then I need to import, if we're going to use the GPIO pins, what do we have to import? What was that? I heard one of you said rp little I dot GPIO as GPIO. Import RPI GPIO as GPIO. Okay, that looks good. Now what do we have to do? We got to tell it what numbering scheme we want to do. Okay, and that's not an import. What am I doing? Okay, that's a GPIO dot set mode. And then what do I want to set mode as? I want to set mode as GPIO dot, I like the physical pins, so what do I say? BOARD. Okay, BOARD. And in BOARD, this is going to be, the control pin is going to be pin 1, 3, 5, 7, 9, 11. Remember, it's going to be 11. Okay, I just like, if I'm writing a real program, what I'm just going to say is red. I'm going to set a variable is equal to 11, is equal to 11. All right, and that way I can just refer to red instead of having to type in 11. And also it makes it easier if we want to change this in a minute. Okay, now we did the set mode. Now what do we got to do? We got to tell it GPIO dot what? Dot set up. This is whether it's going to be an input or an output. So now instead of putting 11 here, what do we put? We're just going to use red because that's the red LED. And then what we're going to say is that that's going to be GPIO dot what? It's an output. Okay, so this is like the old Arduino pin mode that we do here. All right. Now let's see if we can turn that thing on. So we're going to say GPIO dot output, and then what are we outputting to? Red, and then we are going what? Red, comma, true. Okay, then let's go time.sleep. Now you see why I was bringing that in. Let's say for 1 second, it's going to stay on, and then we're going to go GPIO.output, and then we're going to say red is going to be false. Okay, and then we're going to go GPIO, we're going to go time.sleep, so we're going to pause for another second, and then we're going to go GPIO.output red, and then we're going to go red, we're going to go true, and then we're going to go time.sleep of 1, and then we're going to go GPIO.output, and then we're going to go red, and we're going to go false. Okay, so that turns it off. So it's going to turn it on for a second, off for a second, on for a second, off for a second, and that's going to be our program. We should see the LED blink. Now, what do we always do at the end of the program to make sure that we leave cleanly and don't leave a mess on those pins for someone else to clean up? We clean up our messes with a GPIO dot clean up, like that. Okay. What is the chance I did this without making a mistake? Not very good. How do I save the program? Control O. It's saying file name to write. Yes, blink.py, enter. And then how do I get out? Control X. Boom. Now, let's just run the program. So I am going to say Python, and I want a Python blink.py. Uh-oh, it doesn't run. Why does it not run? Because I ran Python as Pi, and lowly user Pi does not have access to the GPIO pins. What did I need to do? I need to run a sudo. So I need to say sudo, okay, and then Python, and then what's my program? Blink.py. And remember that you've got to use your path names. I can do this because I am in the same folder as Blink, and because I'm in the same folder as Blink, I can just type in blink.py. If I was in a different folder, I would need to work my way down like you learned in the Linux lesson. So now let's look and see what happens. All eyes on the LED over here. You can see that it's off, and let's go. Boom. On, off, on, off. Boom. It ran it, and there were no errors. And so we wrote our first Python program on the Raspberry Pi controlling the GPIO pins. Yay! Remember, you got to run them as sudo. You got to run your programs as sudo. Okay, let's think a little bit about those pin outs. All right, let's go back here and let's look at the pin outs. Okay. I am sorry for that interruption. I was just summoned to the office because my BeagleBone Blacks are here. So you can anticipate a whole new series of lessons on the BeagleBone after I finish the ones on the Raspberry Pi. Actually, there's some very exciting things about the BeagleBone I think you are going to like. And so we're going to know the Arduino, we're going to know the Raspberry Pi, and we're going to know the BeagleBone. And each one of those has its own set of advantages and disadvantages. But back to our pinout. Okay, so if we look at this, we are on the 1, 3, 5, 7, 9, 11 pin. We are on the 11 pin as far as a physical pin. But let's go back up here if I can. And if we look at this physical pin, which is the board numbering system, we are on pin 11. But if we were using the BCM, it would be pin 17. So let's just go in and let's see if we can use that other numbering scheme just so that we have a little experience using both. And so what we are going to do is we are going to nano blink.py. This was our old program. And where we come up here, what we want to do is we're going to use the other numbering scheme. So that would be BCM. You know, I always forget that you can't use the mouse. You know, I use the mouse and I think I'm here, but really I'm here as the cursor. I had a student who was playing around. I mean, he was in Linux on the terminal window. Kept seeing him make up commands like activate mouse, enable mouse. He's just randomly guessing things, trying to get his mouse to work in the window, but to no avail. It'll be interesting when I show him that these things will actually boot up in a GUI interface. But I digress. Okay, so we come down to GPIO set mode, and instead of board, we want to do BCM. And then just to verify, this was BCM, or physical pin 11 is under the BCM scheme, it would be 17. And so what do I need to do? Now I need to say red is 17. Oops, and I keep doing that. I did it with the mouse again. Okay, so we're going to come back, and now red is 17. And so this should work because it's using this command. Also, I did GPI cleanup here, and so I shouldn't get any errors. I should have freed it up the last time I was running it. So let's do a Control O to write our changes, Enter, and then Control X, and then we're going to do Python blink.py. Denied. How come? I didn't use sudo. You have to run these things as sudo. Okay, sudo python blink.py. And now all eyes on the LED. We're now using the other numbering scheme. Is it going to work? 1, off, on, off. Yes, we can now use either numbering scheme, either board or for physical pins, or we can use the BCM for the other pins. So hopefully that clears up some of this stuff. Okay, so let's just play around a little bit. Let's go back to nano blink.py. Okay, we come down and we do all of this stuff. This is all kind of setup stuff. Okay, so let me come right. I'm about to use my mouse again. Okay, so let's come here and then let's say blink num is equal to input. So I want to get user from the input. I want to get input from the user, and then I put here how many times do you want to blink? Question mark. Always put a space there so that when they give an answer, it's not against that question mark. Okay. Now close that. Now let's say for I in range from 0 to blink num, like that. Now let's think about this just for a second. That remember when you use the range command in Python, it goes up to blink but not. It doesn't do that. So if I said 5, it would go up to 4 but not 5. So how is it going to blink 5 times? Well, I start at 0. So if I start at 0 and stop here, then it should work. If I started at 1, then I would need to go to blink num plus 1 because it wouldn't go all the way to the end. So you got to kind of think this is a little bit goofy the way Python does these things, all right? So now what I would need to do is I would need to put these in the for loop by tabbing, okay? And then I think what I would want to do is I would just want to say, yeah, I got to turn it on, wait, turn it off, wait. So I say output is true, wait, output is false, wait, and then I don't want to do these other ones because I'm doing the blinking by being in the loop, okay? And then I do need to save that cleanup. All right, very important, something to think about. Would this cleanup be in the loop or not in the loop? It's not in the loop. If you put it in the loop the first time through, you'd clean up and then it'd forget all this stuff up here and it would crash. So you only want to do the cleanup as you leave the program. So kind of like the last thing that you're going to do. How do we save it? Control O, enter, Control X. Okay, let's see. Sudo python blink.py. Okay, ooh, blink num. Oh, I think I see. I think I see. Let's see. Sudo, so nano python dot blink. You can, or nano blink dot py. You can see I'm a little rusty on my Python, but I think what I needed was I needed a closed quote here. I didn't close my quote. Hopefully you guys found that. I hope that's what's wrong. I hope I know how to do an input. Okay, Control O, enter, Control X. Okay, sudo python blink.py, and here we go. How many times do you want to blink? I think I want to blink 5 times. All eyes on the LED. Enter. 1, 2, 3, 4, 5. And we did it. We blinked 5 times. How would we do it again? Well, let's run it again. Okay. Let's say I want to blink 2 times. All right. 1, 2. Okay. So now you see you can turn it on, you can turn it off, you can write it inside of a Python program, you can have it where it's doing what it wants. So now that you can kind of turn it on and off, you can go and you've got a whole bunch of GPIO pins to work with. You can work with a bunch of LEDs. Your assignment, I think, would be to, how about this, so that you really get familiar with this. Build a 4 LED circuit and make a binary counter where you go like 0, 0, 0, 0 would be off, 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 and then 0, 0, 0, 1 would be off, 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 on, and then off, off, on, off. You know, where you cycle through those 4 LEDs side by side as a binary counter. And with 4, I think you can go to 16. From 0 to 15 you can do with 4 LEDs. So why don't you guys give that a try? It'd be a great little project, get you sort of up to speed on bringing back, remembering some of the stuff with Python, and remember playing around with more of these pins, because you just got to go in and start developing that same familiarity with these pins as you had on the Arduino. Okay, this has been a great lesson. Paul McWhorter, TopTechBoy.com. Tune in again. Probably the next lesson we're going to learn how to do more of an analog out, like a pulse width modulated out pins. That'll be the next lesson, and then we'll come back and kind of learn how to do some input stuff. Appreciate you guys tuning in. If you like this, give me a thumbs up. Think about sharing the video. Make comments, man. Give me some feedback. Okay, we will talk to you guys later.